Okay, so some things to be done. Circuit components. There's the wire here, resistor, battery, light bulb, and the switch. Those are the basic components that we have. Uh, then you have the different tools, measurement tools, the voltmeter, the ammeter, and the non-contact ammeter. You can change the look of things. So you can see here it's a schematic like a circuit diagram. Otherwise you can click lifelike and it will look like real value. Yeah, you can click on show values and it will show the values of the resistance or battery voltage or whatever it is. Yeah, so that's so let's construct some simple little thing. Yeah, so we click and drag. That's our battery. So one end, so if you click on the ends you can rotate it. Yeah, so that's what we have. Then we can click a wire, and when you get it close it'll snap. Yeah, when you get it to a place where it can actually connect, it will snap. Get another wire. Let's connect resistor there. Let's have another wire. Yeah. Let's have another resistor here. Let's say another wire here. Let's put a bulb somewhere up there. And let's have another wire connecting that side. Let's have a switch here connecting there, and a wire on the other side. And then we'll close this with a wire, a resistor, and another wire. Alright. Now the switch is open, so nothing's happening. If I click on the switch part of it and close it, drag it, you can see now that the electrons are flowing. I hope you're able to see that. Okay, the bulb is from my end, you can see it's barely lit. Okay, that's because there's too much resistance all over the place. Let's increase the battery voltage. Yeah, so we can right click on the battery. It says change voltage. I click on change voltage. It starts with 9 volts. Let's change it to, let's say, 50. Yeah, and then we click done. Now you are able to see that the bulb is actually shining. Yes or no? Yeah. Now I can change the resistance. So right click on a resistor. They all start with 10 ohms. I can change it to 100 ohms, let's say. Done. And you can see now the bulb has become dimmer. Okay, so that's just making the circuits. Now for the measurements aspect, let's click on the checkbox for the voltmeter. You can see the voltmeter shows up. No, it is possible to burn out a circuit component. Yes, definitely. No denying that. So it is possible to do that. Yeah? But here what they're doing is, I think what you mean. Let me okay, let me just change some slight bits here. Yeah. Yeah, so you can see that it seems to be indicating that the battery is on fire. What is happening here is that you have caused a short circuit of the battery terminals, and as a result, there's too much current flowing through the battery, and therefore there's a lot of heat being generated. That's what they're trying to communicate through that. Okay, anyway, going back to this, my voltmeter is here. Yeah, it shows up. I have 2 terminals. So let me connect the black terminal, let's say here, click and drag, everything is click and drag, um, the other one there, and it reads 7.69 volts. I can move it to the other end of the bulb, and now it reads 3.85 volts. Okay, so that's a simple way of measuring a voltage connected between the points that you want to measure. Yeah, so there. Yeah, very simple thing. Now the ammeter, the regular ammeter, is a difficult little thing to do. Yeah, because what that is you have to connect it inside the circuit. Yeah, so we will not be using that one. Yeah, what we will be using is the non-contact ammeter. Okay, that's much easier. If I say measure this the current in a certain branch, it's much easier to do that. Hold on. Yeah, so if you clicked on the non-contact ammeter, it will show up here. Yeah, that's the thing you can move. You need to move it over a wire. Yeah, so if I move it over a wire, I can see that that says 0.38 amps. Okay, um, let me make it a parallel circuit. So there you have whoops, I have to split this junction. Yeah, join that there. Yeah, these things don't end up looking very good. Yeah, alright, let's say that's there. Let me have another resistor here and another wire. So we got some sort of a parallel connection going on. Yeah, so you can see if I move the ammeter here, this is 0.14 amps. Here it is 0.29 amps. Yeah, so you can see that there is a different current flowing through them. Yeah, so to answer your question, why is the voltage negative? This end here is the negative end of the battery. The other end is the positive end. Yeah? So anything closer to the negative end of the battery will be at a lower potential. Technically, you want your lower potential to be the black wire to be at the lower potential. So technically, that's the way you should be reading it. But if you interchange it, that just means that the black um, probe is at a lower uh, potential than the is at a higher potential than the red probe. Yeah. Okay. So that's that. Is that okay? Does that answer your question, Abhishek? Yeah. All right. Now there are other things here. There's the grab bag. Uh, we don't know the resistances here. Yeah. So you can click on dollar bill and the dollar bill shows up. Yeah. Right click and remove it. You can click on the paper clip or the penny, all sorts of things. Yeah. So we'll be I'll be asking you to choose one of these and determine what the resistance is. Yeah. That's another issue. In the advanced tab here, if you look at this, if you click show, the possibilities here. Yeah, your wire, you can change the resistivity in the wire. Right now there's nothing. Yeah, so if I measure the voltage across a section of wire, you can see right now this is just wire, so 0 volts. I can change the wire resistivity. Yeah, and now you can see that the volt meter is actually registering some kind of voltage. Okay, now the problem with this is it is a little it is very qualitative here. I don't have the length of the wire, I don't have the the diameter or anything like that, so I can't quantify the resistance really. Yeah, but I can measure the total. I can find out the total resistance. Yeah, simply by looking at what the battery voltage is. Yeah, what the total resistances that I know are, and then what is left over to provide the current that we have. Yeah, so the current being provided by the battery is 0.41 amps. I need a certain amount of resistance for that. So whatever is needed to make up that resistance, that will be the wire resistances. Yeah, totally. Yeah, I won't be able to split it into this section has so much and that section has so much and all that. Yeah, that's not possible. Okay, now those three files that you had to download, circuit 1, circuit 2, circuit 3, you need to click on load for those. So you've saved it on your desktop. Click load. The first time you do this after opening this applet, you'll get the warning. Yeah. Do you want to allow this? Yeah, it's asking for read write access to some file on the machine. That's basically what it's saying. Yeah. So allow it to do it and click OK. Your regular Windows open menu will show up. Yeah. So let me navigate to where we have our things. Okay, so here you can see circuit 1, circuit 2, circuit 3 are there. Let's say I'm loading circuit 1. There you go, that's circuit 1. Yeah. Now you don't know what the resistances are. I've changed some of them. Yeah, so I'm going to be asking you to analyze this. Yeah. Now I expect you to be uh, honest about it. Yeah. You can always right click and find out what the resistance is, or right click and say show value, and it shows you. Yeah, but I would like you to actually do this as an experiment rather than as an electricity experiment rather than a computer experiment where you can find out bits of information. Yeah. So again, move it over, find voltages across various components. That's what we're going to be doing. Yeah. So you know what the current flowing through it, you know what the voltage across it is. Very easy to find the resistance. Okay, so that's basically what we are. I'll be asking you to do. I'm going to ask you to verify uh, the rules that we developed. The series combinations, the parallel combinations, etc., and then determine one of the unknown resistances as well. Is that okay? Now, if at any point, let's say you've run out of time, you're trying to construct something, you're doing an experiment, you want to save your work, please click on save. Yeah, and again, you get this thing. If you come up and you get your save menu, save it on your disk with whatever name you want, so you can retrieve it later on. That's basically it. Yeah, and then you can just load it and continue where you left off rather than start from scratch. This is it gets complicated. Yeah, as the circuits get more complicated, you need to not lose your work if possible. Okay, so that's that. Any questions on this? All right. So